We had a vote on whether this statement is true or false. The statement is if f is always positive, then f inverse exists. And the answer is false. When you say this is false, you want to come up with a counterexample showing that it is false. Let f of x be x squared plus 1. Define on the domain on all real numbers. Then this function is positive everywhere, but it is not one-to-one. Since it is not one-to-one, the inverse does not exist. Next, we will talk about how to graph the inverse of a function. We will draw these two graphs, but first let's do this one because it looks easier. First, I will draw the graph of y equals x cubed. To turn this graph into the graph that we want, I can just shift all of the points up by 4. The point 0, 0 turns into the point 0, 4. The point -1, -1 turns into the point -1, 3. Next, I will draw this graph. First, I will draw the graph of y equals cube root of x. I draw this diagonal line, y equals x, and I reflect all of the points of this graph with respect to this line. So this is the sketch of my graph. And to turn this green graph into what I want, I would shift to the right by 4. My 0, 0 point turns into 4, 0. My 1, 1 point turns into 5, 1. And this is the sketch of my graph. In general, you can get the graph of y equals f inverse by doing a reflection across the line y equals x. So if I start with this graph and take the line y equals x, and I reflect every point on here, I will get this other graph. Here are some similar questions you can use for practice. The answer is in the textbook. We voted on this question. What is the derivative of the function x cubed at x equals 0? The answer is 0. One explanation is to look at the tangent line. So the tangent line is this horizontal line, y equals 0. The slope of any horizontal line is 0. So the derivative of the function at 0 is 0. You can also algebraically compute f prime to be 3x squared and plug in 0 for x. We also voted on this question about the derivative of the inverse function at 0. And so it might not be immediately clear from the picture, but the tangent line here can be computed to be this vertical line, x equals 0. At the point where the tangent line is vertical, the derivative is not defined. So the derivative does not exist at 0. Next, we will talk about how to compute the derivative of the inverse function. One benefit of this is sometimes we cannot really compute the actual inverse function, but with what we're going to learn, sometimes we're still able to compute the derivative of the inverse function, even if the actual inverse function is hard to compute. So now let's look at these two functions. They are inverses of each other. Let's look at this one first. This is the graph of the original function. And let's consider some point. Let's call it b comma a. So here I want to consider the slope of the tangent line. Call the slope m. So m is the same as f inverse, or sorry, m is the same as f prime of b. So m is the derivative of the original function at b. Just to help us know what's going on. So a is f of b. And by definition of inverse function, b is f inverse of a. Now, since f inverse of a is equal to b, the point a comma b, so here b is f inverse of a, is a point in this graph. Looking at this picture, let's draw this tangent line. And actually, let's first write down where a comma b is. So this would be b, and this is a. So the point a comma b is somewhere here. And we can compare the slope of this tangent line and the slope of this tangent line. So this is not a proof, but the slope of this one is actually 1 over m, where m is the slope of this one. And this idea always works as long as m is not 0. Let me rewrite this. So if m is not 0, then we know that f inverse is differentiable at a, and we know how to compute the derivative of f inverse at a. It's just 1 over m. This might look a little bit confusing. So here we have f prime. So f prime just means the derivative of f. And when you have f to the power of -1, that's meaning that this is f inverse. So if you are trying to remember this formula, just maybe think of this as this symbol m, where m is the derivative of the original function, but instead of at a, you have to replace it with b, where b is f inverse of a. Let me now write the more formal statement. If the following 3 conditions hold, so if f is differentiable and f is 1-to-1, meaning f inverse exists, and if the derivative of f at the point we're trying to calculate is non-zero, in math symbol, that is f prime of f inverse a is non-zero. If these 3 conditions hold, then we can say that f inverse is differentiable at a, and we know how to compute the derivative of f inverse at a. It is just 1 over this value here, which was our m in the previous slide. Next, we will apply this theorem to an actual function. Normally, we would only use this if we are having trouble computing the derivative of the inverse function directly. But because we're just learning, we're actually just going to use the function we saw earlier. So we start with this function. the cube root of x minus 4, and we're just going to apply the formula directly to compute the derivative of the inverse function. The first step is to just compute the derivative of the original function. This is something we did in the last lecture. Next, we compute a formula for the inverse function. We also did this in the last lecture. And now we will write down f prime of f inverse of x. So what I will do is put this into this formula. So I have 1/3. And actually, I'm going to use this one because it's easier to write. And in place of x, I would write down x cubed plus 4. So this gives me 1/3 x cubed to the negative 2/3. So I have 1/3 x to the negative 2, which is 1/3 x squared. So we have now computed what we were calling m before. And to apply the theorem, we will just do 1 over this m. So then I have 3 x squared. Now it seems a little silly to go through all this because we already computed the inverse function, and we know the derivative of this function is 3x squared. But again, we're just practicing. In reality, we would apply this theorem to much more complicated situations. We did these exercises in breakout rooms. When I wrote KA, that means I took them from Khan Academy. So for this first question, I can use the formula directly. I see that f of 5 is equal to negative 2. So that means f inverse of negative 2 is 5. And in fact, that's already given in the table. So I replace f inverse of negative 2 with 5. So now I just have to compute f prime of 5, which is negative 1/2. So I get negative 2. So for number 2, the statement says if f prime is always positive, then f inverse is always increasing. Here, I'm going to assume actually that m inverse exists. So the statement, if f is 1-to-1, meaning the inverse exists, and f prime is always positive, then f inverse is always increasing. This is true, and we will use the theorem 7 to explain why. If the derivative of f is positive for all a in the domain of f, then I can write f prime of f inverse of b, and anything I put in here would still be in the domain of f if I'm talking about b that are in the domain of f inverse. So this is also positive. And so I can compute the derivative of f inverse using that formula. That is just 1 over this value. But that value is positive, 1 over a positive number is positive. And because the derivative is always positive, f inverse is always increasing. In this next exercise, we are given the inverse function. It is a polynomial, but actually it is hard to compute the function f. And so now we want to compute the derivative of f at 0 without actually computing the function. And I'm telling you not to compute the function because we haven't learned how to do that. And that's not something we're going to learn in this class. So the hint is to use this and to use the formula. So this is the formula. And my goal is to compute f prime of 0. Now, where do you see f prime in the formula? I see that there is this f prime. And if I know how to compute, I know how to find a so that this value becomes 0, then all I have to do is compute this value. Since I know what f inverse is, I can compute the derivative of f inverse. Right, so in order to get 0 here, I just have to put in 1 for a, right? So since f inverse of 1 is 3 minus 2 times 1 minus 1, which is equal to 0, let's plug in a into the formula. So now I plug in 1 into here. And so this would become 1 over f prime of 0. And I'm almost done. I just have to compute this part. The derivative of this function is -2 minus 3x squared. And so the derivative at 1 is -2 minus 3 times 1, which is -5. So then I can compute f prime of 0 from over here. So I have 1 over this value. So f inverse prime of 1, which I had just computed, that is -5. So this is the final answer. We will have our first quiz next Thursday. It will be on 6.1 and 6.2, and these are the study guide. It will be proctored over Zoom, so make sure you have a video camera and microphone that works, and if not, please talk to one of the instructors so we can help you borrow an equipment from the library. And again, note that all assignments are on Canvas under assignments. I included optional but recommended exercises. If you have time and if you're trying to get an A, you might want to do the recommended exercises. The required homework is very minimal.